there. So in this video, we're going to look at adding and subtracting polynomials. So I'm going to look at this entire, basically the entire front page here with you, except in example one, I'll let you try the last couple there alone. But it says here at the top, congratulations, you've been accepted to UNCW's extension program and plan to pursue a BA in criminology. In-state tuition for 2012-2013 school year is $139.88 per credit hour. So in part A, it says, well, in the fall semester, you pay $300 for your textbooks and take 8 credit hours. They want us to write a polynomial that would calculate your total cost for the fall. Okay, so let's write this little expression here for us. So we want our fall cost. So we know that we are going to pay $139.88 per credit hour that we take, plus $300 for our textbooks. All right. In the spring semester, it says you have to pay off a $14 parking ticket, $400 for books, and you take 8 credit hours. And they want us to write a polynomial expression here that would calculate your total cost for the spring. So we'll label this as our spring cost. And this time, we're still taking our credit hours, so $139.88 per credit hour, plus our $400 for books, plus this time a $14 parking ticket. Now, you'll notice here in letter B that I have like terms within this expression. So we can clean up our expression by adding those two pieces together and write this more simply then as $139.88 per credit hour plus $414. All right, that would be able, we could utilize then this expression to get our total cost for the spring semester. Part C now wants us to write a polynomial that would give the total cost for both your fall and your spring semester. So your total cost would be equal to your fall plus your spring. All right, so now let's fill in. We know that our fall expression is this, 139.88H plus 300, plus our spring expression, this one, 139.88H plus 414. Now, to get our total cost then, we would just combine like terms. We have h's that we can put together, so if we were to add those two h's together, that should land you at 279.76h plus, and then add your numbers together. So 300 plus 414, that should land you at 714. That would be our final answer there, for that would represent now your total cost for the spring and fall. Part D then wants to know to use our polynomial to find the total cost for the year if you take 12 credit hours per semester. So our cost then would be equal to 279.76, and in place of those credit hours, we're going to put in our 12 plus 714. So now we would just put this, we could put this in our calculator all at one time. The 279.76 times 12 plus 714, you should land then at $4,071.12 as a final answer there. Okay. All right, so I've already been utilizing some of the terms that you're going to see me start mentioning down below, but you would picking up some new ones as well. So some terms of polynomials. So a term is just a constant or a product of a constant and a variable, or variables. Terms are the building blocks of what we call polynomials, and terms are always separated by addition and subtraction signs. And when the combination of terms is added or subtracted together, different types of polynomials are created. Some examples of polynomials are a monomial, a binomial, and a trinomial. And if you have more than 3 terms, you're referred to as a polynomial. Okay, so a monomial just means that you have one term. So it could be one constant number, it could be a combination of a variable and a constant, or several variables and a constant. These are all examples of a monomial. Binomial, think bi means 2, all right, should have 2 terms. And remember, terms are separated by addition and subtraction signs. So here's a binomial, binomial, binomial. Each of those have 2 terms. Trinomial is going to have a polynomial with 3 terms. And so each of these are examples of polynomials with, of trinomials, polynomials with 3 terms. Okay, so coming down then below in example 1, it wants us to identify the terms in each of the following polynomials. Label the polynomial then as a monomial, binomial, or trinomial. Okay, so if I'm looking at my terms then here, I'm just gonna underline them here, that my terms, remember, are separated by addition and subtraction signs. So here's a term, 7x is a term, and this negative 10 is a term. So those are our three terms for this polynomial. And so since it has three terms, it's known as a, hopefully you agree, a trinomial. Okay, I encourage you pause the video and try B and C now. Okay. All right, let's flip it on over then to the next page. Another way that we can describe polynomials is by looking at their exponents. And what the exponents to help you determine is the degree of that polynomial, okay? And the degree of a single variable polynomial is the highest power of the exponent on that particular variable. So the example below says, let's find the degree then of each of these terms. So remember, it's the exponent on your variable. So for example, here in the first one, 5x, well, the exponent on that x is an imaginary 1 sitting up there. So the degree then for that particular term is just 1. The next one, exponent on that x is to the 4th, so the degree here of this term would be 4. In the third example here, I don't have a variable term. So that means then the degree is equal to 0. And that leads us right into the fact just down below that, and it says the degree of a constant term, meaning just having a number to it, is always, always, always 0. So the degree of a constant number is always 0. I will let you try example 2 then, from top to bottom. Check yourself by the solution key. Let's come on down and let's find the degree of a polynomial. So the previous examples were just finding the degree of one single term. Now we're going to expand that and find the degree of a polynomial. What you first do is find the degree of each term, and then the highest exponent is the overall degree of that polynomial, okay? A nice way to do that too is that if you write your polynomial in descending order, then your first term should be, the exponent on that first term should be the overall degree, okay? But you can still do it as I'm going to demonstrate here. Find the degree of each term, and then the highest number is the overall degree of the polynomial. So if I look at this first term, so remember I've got three terms here. Here's a term, and here's a term. They're all separated by addition and subtraction signs. So the degree of that first term, look at the exponent there, is 3. Degree of that second term, imaginary 1 sitting up there, so the degree of that term is 0. And then the last term, the degree of any number is 0. So then what that tells us then is we pick the highest, so the overall degree of this polynomial is 3. Okay. So down below in example 3, I say for the given polynomials, rewrite in descending order if it's not already in that order, and then find the degree of that polynomial. So I'm going to do example letter B here with you and let you go back and try A and C, okay? You'll notice in letter B here, this is not what we refer to as being in descending order. By being in descending order, you start with the highest exponent and then go down, okay? So here, my highest exponent then would be that 2x to the 5th. I can mark it off, and then I'd move to my x cubed. Then I'd move to the 6x, and then I've got my minus 7. And I'll demonstrate one more time. I can look at each individual term, find the degree of each term. So the degree of each term, this time we've got 4 terms. So the degree of that first term, just look at the exponent. Degree of the second term. Degree of the next term, imaginary 1. And the degree of any number is always 0. Go through those, you pick the highest. The overall degree then here would be 5. Okay, but like I said, if you take the time to write it in descending order, then that very first term is going to be your overall degree, the exponent on that first term. Okay. All right, so now let's move into adding and subtracting polynomials. Just like we added and subtracted like terms whenever we were solving equations, you will do the same thing here with polynomials. You will add and subtract, meaning combining like terms within a polynomial, okay? So if I'm coming down then to example 4, let's just do letter A here together. I think these are pretty straightforward in terms of combining like terms. Remember, you have to have the same variable part. All right, so I've got an 8a squared in the first parenthesis and a 2a squared in the second parenthesis. So they have the same variable, the same exact exponent, so those are considered to be like terms. I combine them, so 8 plus 2 gives me 10, and then you keep that variable part, okay? Then move to your next term. I've got 4a and 3a. Combine those. 4 plus 3 gives you 7, Keep that a. Remember, the only time you add your exponents is if you're multiplying, and here we're just adding these two expressions together. And then the last term, I've got this 5 and 7. Add those two together, and I have 12. Final answer. Okay. I'll let you try B and C and check yourself by the solution key. Let's flip it on over then. Last page. Let's look at subtracting polynomials here. The only difference with subtraction is that you'll have a negative sign that needs to be distributed into the second parentheses, or not necessarily always the second parentheses. Just think of you're distributing that negative sign into the parenthesis behind the negative. Okay. Now, of course, I'll demonstrate that for you here in letter A. So you'll notice in example 5, letter A, I've got a polynomial minus another polynomial. So it looks very similar to the previous page where there's two polynomials. The only difference was there was an addition sign. So now we've changed it to subtraction. Well, remember, a minus is the same thing as a negative. And so we're going to treat this then as a -1 that gets distributed to everything in the parenthesis behind it. So that means then that first parenthesis just gets brought down. But now -1 times +4, -4x squared, -1 times positive x, -1x. You don't have to write the -1, but you do have to have the negative x. -1 times -2, +2. I've said this before, I'll say it again. Let your operations determine your sign. You want to get away from using double signs. So, negative times a positive, go ahead and write your minus sign. Negative times a negative, make a positive sign. You don't want to have plus and negative and things like that. Now combine like terms. So 6x squared minus 4x squared gives you 2x squared. If you want, you can mark those off. They're taken care of. Now move to your next term. 3x minus 1x, positive 2x. Mark those off. And then move to my numbers. 9 and 2, both positive. Add them. It gets you 11. Final answer. Okay. I will let you repeat that then for B and C. D just wants the total measure of those two angles, so we would be taking those two expressions there and adding them together since you want the total measurement. I'll let you do D. Let's come on down to E though. E says that your profit equation is given by this expression here, that profit is equal to revenue minus cost. And they want us to find the profit if the revenue is given by this expression and the cost is given by that expression. So here's what it's going to look like then. In place of revenue, I'm going to put the expression 12x squared minus 2x plus 4. And in place of the cost, I'm going to put that expression 3x squared minus x plus 1. Notice how I put that second expression in parentheses. That one had to be in parentheses because I've got a minus sign sitting in front of it. And so remember, that minus sign is like a -1 that has got to be distributed into the entire cost function back there. So I'm going to bring down my revenue. Nothing's going to change in that one. It's only what's behind the minus sign. -1 times 3x, -3x squared. -1 times -1x, negative times negative gives me a positive x. -1 times +1, a -1. Last step, let's combine like terms. So 12 minus 3, 9x squared. -2x plus 1 gives you a -1x. You don't have to write that 1. You can just write minus x. And then lastly, +4 minus 1. So 4 minus 1 gives me a +3. Final answer. Okay, that finishes up this section. Thanks a lot. Bye.